Hi guys, it's Group 21's final project present time, and I'm gonna introduce why do we do this project and the background. So many students in NTHU suffering from the decision disturbance, like you have the difficulty choosing what to eat when dinner, breakfast, or lunch. So we invented an app try to figure this out. So we can combine your goal, either gain muscle or lose weight. And we will depends on these two goals and your personal profile like height, weight, or time you want to achieve your goal to recommend the restaurant you can eat. And then we will combine the camera to analyze the food, calories, and the protein and record those things that you're to create your database. So this is our app, SnapEats. Okay, so we are going to introduce our methodology now.
I will give you a brief overview of our project. We start off with Google API. This allows us to get the photos from the reviews section of the Google API. We do that and we download the food items corresponding inside a folder to the restaurant. Sometimes we have images that do not correspond to food items. Therefore, we have to manually filter them out. Once we have done that, for each restaurant, we have the food items, the food photos from that restaurant. So we input that into the LogMeal Macros API, as well as the Google API. This allows us to track the protein, calories, latitude, and longitude. The latitude and longitude correspond to the restaurant location. The protein and calories is an average of all the food photos taken from that restaurant. After that, we upload that to the code locally. To train our neural network, we use a Kaggle database, obesity.csv. Our data is represented as follows: gender, age, height, weight, weekly calories, weekly protein, and the output is weekly weight change. Once we have trained that model, we will have the calculated weekly weight change, scale it up PKL, and then up PTH. These two correspond to the trained model. Now we have uploaded in our backend, the Google Drive, our representation of our trained model. Going into the app, the user first goes into the user profile. We can either load pre-existing data from our backend or submit new data to our backend. Now we have height, weight, age, and gender values, as well as our goal, either lose fat or gain weight. Using that, we can now create goal protein values and also goal calorie values. Those values serve to create a list of greatest and lowest fit restaurants for our goals, as well as using the pre-existing longitude and latitude values to check where that restaurant resides. Now the user can go to that restaurant, place which date they have visited this restaurant, and submit the photo for review of the calories and proteins that are present in the food item they are currently eating. We upload this to our Google Drive backend as foodchoices.csv. Now we can calculate the actual protein and calories which the user is currently eating. Doing that, we can now create a chart where today is the current weight that the user is at, and we can use our trained neural network as well as the food macros, the protein and calories, to predict how the weight change of the user under their current food choices.
So this is the home page of our application. From here, the user can navigate to the other pages and use their features. On the home page, you can find the calculated nutrition goals for our user. And on the bottom half, we can see the titles for recording each day of the week. From the bottom navigation bar, the user can direct to their profile page, where they will be prompted to enter their details. This information will later be stored in our backend and used for our calculation for their nutritional recommendation. Furthermore, there is the camera page, where the user can take pictures of their food, as well as select their current day. As mentioned before, on the tiles page on the home page, the user can tap on the tiles for their day to see their record. On the record page, the user can see the recorded photo as well as the table that shows the nutritional values of their meal. These values are from passing the photo through LogMeal API to calculate nutritional data.
Regarding the map feature, we recommend restaurants that best align with the user's dietary goals. As shown here, the green ring indicates how well a restaurant meets these goals. The database we trained was built using images collected from Google reviews for 60 different restaurants. When you click on the restaurant, it shows the location in the upper part.
So here our graph page. So it's for tracking yourself and the prediction. So basically, as you can see, let's say we started at 100 kg, and then the blue line is the prediction, and then the green line is our current weight. So as you can see, like as we predict the weights weekly, the user weights will follow the prediction. So it actually like fits and help you to achieve your goal.
Okay, I want to talk about our training results. This is our training model. This model collects data from Kaggle. obesity.csv, and the obesity.csv have some data like how much or how many meals one people eat a day and like what is the meal. But our model needs to input the how much calories and how much protein the people ate in a week. So I did some pre-processing. After the pre-processing, my predict is somehow really accurate because the training loss and the validation loss all drop together. This is the testing result. Like a person actually uses the model and predict his weight change. And the blue one is the actual weight change. And the orange one is the model's predict. And it is closer and closer. This is the difference between the last picture's orange one and the green one. So that the model error, we can visually see that it is lower. Like not the same from first picture. The first picture is the training process. This is the testing process.
To conclude our presentation, we have our project goal is basically to make our user to have a better lifestyle and a healthier body. And our methodology is basically we do the pre-processing and we filter the data, get the user profile data, do the neural network based on their calories intake and protein for weekly, and then to get those output we make the CSV file and we can make the prediction. And then our app features including the maps and also the camera, the graph, and also our expected outcome is like the user weight history will follow the prediction plot. So our future potential, we want to connect the prediction graph to our NN, so it will update automatically and predict it automatically. And we want to provide more robust description about the food for the user, so our user will have more knowledge in healthy lifestyle. Thank you.
Three,
Hey.
2, 1.
Three, 2, 1. Thank you.
Thank you.